Dear students, welcome to another lesson, and this is our lesson 5 on indices and logarithms. Today we are going to focus on solving equations involving indices, and here we are going to take indices problem that lead to linear equations only. The subsequent lessons will also take quadratics and simultaneous equation respectively. To start with, there are equations that involve exponents as variables, and these equations are called exponential equations. For instance, assuming we have a exponent x which is equal to a exponent y. From indices, since the bases are the same, we can easily imply that the exponent too are the same. So hence x is equal to y. So this is the concept that we're going to apply. So anytime a problem is given involving variables, all that you need to do is that you have to make sure the bases are of the same form. Then from there you quit the what? Exponents. Without wasting time, let's take our first example. So the problem says solve for x in the following, and our first problem is 3 exponent x plus 1 equals 9 exponent 4. What you have to do, you have to change the 9 to the index form, and it should also have the same base as 3. So we're going to have 3 exponent x plus 1 is equal to 9 to the base 3 will be what? 3 exponent 2. But remember, we have exponent 4 over there, so we put it in brackets. They are going to multiply. Then after that, let's find the products. So we're going to have 3 exponents x plus 1 equals 3 exponents 8. Now that the bases are the same, you can easily say that this implies x plus 1 is equal to what? 8. Then we solve for x. So solve for x, we have x plus 1 is equal to 8. We have to move this one there, and that will be 8 minus 1. When it subtracts, we are going to get x to be what? 7. So therefore, our x is equal to 7. I hope it's clear. So it's simple. Example 2. So you need to note that if you have 64, we can change 64 to a base of 4, and that is 4 times 4 times 4. 4 for 16. 16 times 4 is 64. So we can say that 4 exponent 3, and again we have x over there, multiplying the x is equal to 16 can also be changed to a base of 4, and that is 4 times 4 is 16. So we're going to have 4 exponent 2. And then since the bases are the same, we can say that 3x is equal to 2. So in that case, 3 times x is 3x is equal to what? 2. And when you divide by 3, and then here by 3, x becomes 2 on 3. Two exponent 3 x minus 1 equals 128 root 2. So in this particular situation, we need to change the 128 to base 2, and that will be, so 128, how many times should we multiply 2 to get 128? So that will be 2 times 2, that's 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. 64 times 2, 128. To 1, 2, 3, 4, 5, 6, 7. That will be 2 exponent 7. Then the root 2, we can also write it as 2 exponents half. So when you continue, we have to apply the product rule on this. So 3x minus 1 is equal to 2x plus half. And that will give us 2 exponent 3x minus 1 is equal to 2 power 7 and half. When we put it together, it's 7 and half. Now we can equate that, and that will give us 3x minus 1 is equal to 7 and half. We need to change the 7 and half to improper fraction, and that will be 3x minus 1 equals this, and this will give us 14 plus that's 15. So 15 on hold 2. Find LCM. LCM is 2, so that will give us 2 times 3x minus 2 times 1 is equal to 2 times 15 on 2. This produces 2 times 3x is 6x, and minus 2 is equal to, let's cancel that, and that will be what? 15. So 6x is equal to 15 plus 2. 6x is equal to 17, and hence x is equal to 17 over 6. That is that. So try this as your take-home exercise. Find the values of x in the following. Follow the same procedure and solve them. If you face any challenge, let me know. Thank you very much for watching. Please subscribe to support the channel. Bye bye.